Hello and welcome to Go Getter Geeks. I'm Aditya Solge and today we are going to create custom annotations to generate the data access layer. Before we jump into the details, let's explore the concept of data access layer. Often referred to as data access object or DAO, are the types of classes which directly interact with the database. They provide methods for adding, updating, deleting, and retrieving data, a set of operations referred as CRUD operations. Now, let's dive into the annotation creation. Our journey begins with three unique annotations. Let's start with the first one. Before we start, let's create a new package and we'll put all our custom annotations within Annotations package. The first one, we will call it FileDB generated. We'll mark it with @interface, and this @FileDB generated annotation will signal to our processor that this is a model class and for this class we need to generate a DAO. Since we want to generate the code at compilation time, we will mark it with a retention policy of source. Next, we want this @FileDB generated to be used only on the classes, and hence for the target we will specify the element type, and that's it. We don't need any other information like taking in the parameter or anything. We'll keep it simple for this one. Next, we will create another annotation which will signal whether a field must be persisted in the DB or not. So we will call it @persisted. If you are using IDE like IntelliJ, you can directly select annotation and you will notice that it will directly create @interface. Similarly, since this annotation will be used in combination with FileDB generated, so we want to keep it at a source retention level. And the target for this annotation is the field, because we want to know whether a field must be persisted or not. So we will specify element type of field. And that's it for this annotation as well. If you want to expand it, you can take a parameter named as key, so that user can specify two different names, one that they can use for their own DTOs and the one which is used to write on the database. And lastly, we have one more annotation to specify whether a field is a unique key or not. This will help us in methods like update and delete, where we first need to figure out which record we want to perform the update or delete operation. We will name it unique key. And since this will also be used in combination with FileDB generated, we are going to keep the retention at source and target of field, because we want to identify the fields that are unique key. And that's it for all the annotations that we need for our project. Now that we have all annotations created, let's create the processor. For that, we'll create another package and we will name it processor. Within that, we will create one processor class. We will call it FileDB generated processor. In order for Java to recognize it as an annotation processor, we will extend it with an abstract processor. As soon as you inherit this abstract class, abstract processor, you need to override process method. So whenever our FileDB generated processor is invoked by Java, it will essentially pass us two things. One is a set of annotations and a round env. With the help of these two, we will be able to extract key information that we need. For example, the name of the model class, okay, the number of classes which are annotated with FileDB generated, and the number of fields which are annotated with persisted and unique key within each of those annotated classes. Let's look at the code for processing each class annotated with FileDB generated and extract the list of fields annotated with persisted and unique key annotation within each of those classes. We will also extract the name of the model class which is annotated with FileDB generated. We will also extract the name of the model class which is annotated with FileDB generated, and also the package name which we will use to create our new classes. So first we will extract the list of classes which are annotated with @FileDB generated annotation. For doing so, we can call get element annotated with method of round environment class. We can just you can just pass the annotation, name of the annotation dot class. Okay, it returns a set which extends element class. Next, we need to iterate through each of these annotated class and extract the persisted and unique key field. In order to do so, we'll iterate through each element in the FileDB generated annotated class sets. Now, since we know the FileDB generated annotation can only be used on class, so we'll make a check to make sure that the element that we are getting is indeed class, because some user can accidentally or deliberately put those annotation at a field level or a enum level. So what we can do is we can call element.getKind and check that it is indeed a class. Now that we know it's a class, so we'll first typecast into a type element which we know is a class. Next, we will iterate through each element of that annotated class, and by element I mean fields, methods, all that. So we'll iterate through all the elements and then we will extract all the fields out of it. Next, for each enclosed element, we'll first check whether it's a field or not, because as I mentioned, those enclosed elements can be method or enum or maybe inner classes. So we check, we get the kind of this and we make sure it's a element kind of field. At this point we know it's a field, so now we can check whether it is annotated with @persisted, and we can do it inline only by calling get annotation method, and we just make sure it is not null. Okay, when these two conditions are met, we know it is a field and it is annotated with @persisted. Now what do we do once we identify it? So we are going to create a list of these fields. So we are going to create a list of variable elements, and as and when we encounter, we are going to add. Now we also need to identify unique key fields. So the way to do it is we can first check whether it's a unique key, and if it is a unique key, we can assume it already has a @persisted as well. So instead we are going to add a if condition on top. Now you must be wondering, why are we typecasting all of these into different classes? So all of these elements, which can be a field, method or a class, all of these comes under element class. And to make it more specific, there are subclasses of element class. For example, type element represents a class. So the advantage of having it is we can call more specific methods of that class instead of calling the generic methods provided by the base class. And we typecast as in when we confirm that they are of that particular type. Next, we are going to identify the name of the model class and the package. Both of these will be used to name the generated classes, and the package name will help us in put the files at the correct package. So first we need to make sure the persisted fields are not empty or unique key are not empty, because it might be possible where we encounter a scenario where user specified @filedb generated but did not specify any field to be persisted. In that case, we don't want to generate any classes. So as soon as we do that, we'll now extract the name of the model class and extract the package name of that model class. To get the name of a class, the only thing that we need to do is use our class element and get the simple name in a string. To get the package name, there is a one field called processing n, which is of processing environment class. Processing environment class contains all the metadata kind of information like the package name and other information. And this variable or this reference variable is part of the base class, which is abstract processor. So we can call get element utils. We want to get package of class element, and we just put it in a toString and we capture it in a string variable. Now that we have all the required setup, let's dive into creating generic classes. The way to do it is first create the concrete classes and then convert them into generic classes. For example, we know we need one interface having CRUD operation methods declared within it, one DTO class containing only the fields which are marked with @persisted and @unique key annotation. This will help us in directly writing these objects to the files without worrying about excluding the other fields. Next, we need two custom exceptions, request exception and service exception. Request exception represents the problem with the request itself. For example, having null values. And service exception will represent problem at our own end. For example, for some reason we are not able to open the file. And lastly, the implementation of the DAO class, which contains the core logic. And that's it for this video. We are on to the last round where we get to the meat of this project. So I'll see you in the next video. If you found this video helpful, please consider subscribing and sharing this video with your fellow coders. Thank you so much.